Welcome back to the channel, guys. Today we're going to be doing controllers. Let's get these sprites moving. And don't forget, if you like what you see,
like and subscribe.
Today we're going to be doing controllers. Let's get those sprites moving. Alright, let's have a little fun. Let's get to the end before we start diving into the code. So here we are with my title screen. It's called NES Combat. I'm basically doing combat for the Nintendo Entertainment System, so I'll call it NES Combat. Anyway, so we can load backgrounds now, and we went over that in the last video. Now I also have sprites up here that I loaded as well, and let's see if they actually move. There's player 2, going counterclockwise pretty slow, and going clockwise pretty slow, and we'll try player 1, and he goes clockwise and counterclockwise. So I got a sprite on the screen, and I can spin him around. Alright, so how in the world did we do that? First, before I even dive into the controllers, I wanted to touch on banks. Last time I tried to explain it, I didn't fully know it, but now I've got a better grasp on it, and I wanted to let you guys know how it works. So, as you know or may not know, there are many different mappers, and the mappers actually help you arrange or swap out banks as you need more memory. Say if you're doing a big game like Zelda and you need a lot more banks of memory, you would use a different mapper that allows you to map or bring in more graphics, and you would use a bank to hold that graphics. So, for example, in my game, I'm using mapper 0. So that means I get 40K. That's it. For the whole game. 40K. Graphics, code, everything. Okay? So, one of the things that I learned is how the banks actually are dividing up that memory and what it's used for. Okay, so I wrote some notes. I'm going to go over it just real quickly with you before we dive into controllers. I found it to be pretty important. So, when you declare your header file, your header, and your INES PRG and INES char declarations at the very top of your file, you'll notice that there's different numbers that are represented here, and I had a 1 here, and basically what that said was I only want to use one bank because there's an upper and a lower bank of memory. Pretty cool. Well, the upper bank is 16K, the lower bank is 16K, and a lot of times when you view other people's code, when they have a 1 here, they'll start the code off at C0000. The reason is because everything is mirrored between the 8000 and the C, we'll call it 1000, address location. They're mirrored. So you can start it, your first bank, at 8000 or C1000 because you're only asking for one bank of memory, okay? The upper or the lower. That's all that's saying. So I want to get as much memory out of this as I can, available space out of it as I can. So I want 2 of the 16K, PRG banks. So I want both the upper and the lower. I don't want them mirrored as one, okay? So that's the first key that I learned. I was like, okay, cool, got it. So anyway, unless you want to make a really tiny game like Pong, I'd highly recommend putting a 2 for your INES PRG so that you get both 16K PRG banks. Okay, that way you get 32K. Otherwise, you only get 16 because it's mirrored. Okay, and then you still have your 8K for graphics. So 16 and 16 and 8 is 40. That's where you get the 40K memory. So I wanted to give a quick shout out to Mike. I put his channel in the YouTube. You'll definitely want to check him out. He goes deep into his game that he is programming right now. Definitely check him out. He's got a lot of stuff, or a lot of knowledge, and a lot of stuff going on in that game that I'm still trying to catch up and learn. You can also catch him on Discord as Zelius. But there's a lot of guys on there that have been helping me out. So just want to say thanks to everyone. And thanks to you guys for joining and watching me. So I've broken this up into 4 banks. So I'm starting the first bank, which starts at 0 at 8000. And if you, there we go. And my second bank is bank 1. Of course, that's going to start at A0000. And my next bank, I unhighlighted it. Shame on me. There we go. And my next bank is going to, of course, start at C1000. That's bank number 2. And if we scroll all the way down here, you'll see my other banks. There we go. And here we are. So bank 3 is going to start at E1000, and then bank 4 is starting at 0000. Is that too many? 4 zeros. And that's where your char graphics start. Okay, so that's the last bank there. Okay, bank 3, the only thing interesting about that is that's where your reset vectors do have to go. So make sure that you put those in there. Alright, let's dive into controllers. Alright, so let's get this sprite moving. How did I do it? Well, I needed a lot of help. So with NES Combat, if you guys don't remember, one of the cool things was you could actually spin your ship, you know, or tank or whatever it was that you were using, because there was 3 different ones. There was the jet, the tank, and helicopter, I think it was. Anyway, that you could turn in 360 degrees. So one of the things that I wanted to do was to be able to, you know, mimic that and keep that and honor that movement of being able to turn. Okay, flying is later. I'm not there yet. I just wanted to be able to turn. So let's declare a couple variables up here. So for the ship movement, right, I created 2 variables, movement timer and movement timer 2, okay, and ship direction 1 and 2, and buttons 1 and buttons 2, okay. So ship direction is just a byte that allows me to track which direction the ship is actually facing. Movement timer is basically a counter. I don't want it to turn too fast or too slow, or I want to be able to control it. So you can actually start counting frames. So I wanted to count a certain number of frames before it moves. And then buttons 1 and 2 is just a standard way of capturing the full byte of buttons that are pressed on the controller. Okay. I do have buttons 3 and 4 commented out. I'm working on 4-player. Right now I'm just working on 2, you know, walk, then run, then fly. Okay. And then I have a constant down here, which is ship rotation speed. So right now it is value $0A, which of course is 10 in hex. And this is basically how many frames I want it to count up to before the ship moves. So let's get into the actual controller code. So I'm going to go down and show you where the code needs to go after you load your background and you load up your sprites right here. So when your NMI begins, right after your PPU cleanup, you know, code, you want to go ahead and load up your controllers. Everybody's different. I mean, don't take that as solid, you know, biblical, you know, doctrine, whatever. You must put the read controllers here. No, you put it. I haven't really learned enough to know where you can't put that code, but I just know that it should be in the NMI. I just don't know where exactly in the NMI it needs to come. But I would assume at the first or highest point, you know, closest to the NMI, so that it's, you know, reading the controllers as fast as it can, so the movement of the sprites can happen as fast as they can. So anyway, you do need a jump subroutine here to read controller 1, or you can put that whole code in there. It just makes it a little easier. So let's go ahead and read that. So if I go down to read controller 1, let me scroll down here to it. It's all the way down here. Okay. So I put the actual code outside, but the JSR inside the NMI. And then just make sure you end it with RTS and it'll get back. So let's dive into it. Alright, so this section here, I'm not going to get too much into the top loop. Basically, this is from Nerdy Nights. They give you a lot of, you know, like I said earlier, they give you a lot of breakdown on the order of the buttons that are red, how to AND them so you can tell which one is red, and the order is of the bit is based on that, so that you can easily tell if it's on or off. Okay, but let's take a quick look at the code. So the top part is basically saying, hey NES, you know, I wrote a 0 and a 1 to you, so you know that tells you, hey, I want to read a controller. Okay. And that's what it does. So we're going to start off with an 8 in the X register because there's 8 bits. We have to loop through this 8 times. So that's why I have an inner loop and an outer loop. Okay. So the inner loop will basically say, okay, I want the value that's in 4016. And then the LSR and ROL left shift register, I believe it is, and roll on left. I forgot what the ROL actually stood for. But basically what it's doing is taking the bits and it's moving them to the left or the right so that it can easily move to the next bit that it wants to read. So you can go through all 8 of them in a much more efficient manner. So don't try and improve on it unless you're a genius and you can, then great. Tell the community and we'll all start using it. Anyway, so once you do that, it'll have the 8 bits stored. Once it does this 8 times, it'll have it stored into buttons 1, and then it'll go back to the RTS command and go back to where read controller 1 was called. And I have a jump, of course, like I showed you earlier, to read controller 1. Right beneath that, read controller 2. The only difference between these two, the way you tell the Nintendo that you're reading controller 2 is that you tell it to read from address 4017. That's where controller 2 is at. Okay. I do plan on doing 3 and 4 players. I haven't quite figured out the order. I think you do 4016, 17, and then go back to 16 and 17 for 3 and 4, but I'm not sure, so I'm just doing 2 players for now. Also make sure that you're storing that byte in a different variable. I actually had button 1 here instead of button 2, and so when I was moving, it was moving both, and yeah, it was annoying. I was like, how do I fix this? Anyway, so let's get into the meat and potatoes of how this actually works. All right, move ship. So I got read controllers 1, read controllers 2. These are all in my NMI. And now I have a jump to 2 subroutines, move ship 1 and move ship 2. Okay. Before I get into this, Kevin from Con Games, if you were watching this, thank you, sir. This was a pretty slick way of doing it. I hadn't really thought of this, and I was a little stumped. And I went onto Discord and or Nintendo Age and posted a question. I was like, how do I just have the tile turn? It didn't quite dawn on me that, well, maybe you just need to change the tile number instead of the X and Y attributes. Oh my gosh. But anyway, this is how I'm doing it. 99% of this came from Kevin. I've read through it about probably 30 times, and I'm getting better and better at understanding it. So hopefully I don't mess it up. So this is how I'm doing it. If you guys want to, let me know if there's more improvements or a different way to do this or how you did it. Let me know in the comments. So what I first did is, after I've read the controller, button 1 is now has a full byte of 1s and 0s of which buttons are being pressed. The only one I care about right now is left and right. That's it. I haven't gotten to the rest of them, but eventually I will need to. So because of the order that Nintendo Age gave me, I know that left is the second to the last value in the byte. So right there, I don't know if you guys can see that, right there, right? I ANDed it with it, okay? So if you AND it and they're both 1s, then you'll have a 1, okay? So I'm testing to see if it's pushed. So if it's not, break if equal, then I'm going to try right, okay? So then we'll jump down to the right. You must be pushing left or right. And that's all I'm testing. I don't have any other tests. Try right, try left. That's it. Nothing else yet. Okay. So let's say he is holding left. Let's just go through that. So I increment the movement timer. Remember I had a byte up there, so it'll be going from 0 to 1. Okay. I'm going to load that into the A register, and then I'm going to compare it to the ship's rotation speed. So remember, ship's rotation speed was 0 alpha, which is basically 10. So in other words, I'm going to increment movement timer on the first frame. Okay. Does 1, because it incremented from 0 to 1, does 1 equal 10? Nope. Okay. End. Goes all the way down to end and returns. Nothing happens. What? Well, okay. The reason is because I don't want the ship to rotate every single frame. It would spin too fast. It would give everyone seizures, and it would be unplayable anyway. So I wanted to slow it down. Okay, so I can change this value to 10 or 4 or 20. Maybe give the ship a power up so they can spin faster, or maybe it's a bad thing. If you run over a skull crossbone, your guy spins, or your ship rotation speed is now you know, 1. So every frame you just like, bzzz, so you can't shoot anything. I got all kind of wacky ideas, you know, this is going to be a fun game. Anyway, so let's say that they do equal though, 10. So 10 frames went by. Oh no, it works. Okay, so this is going to fail. It's not going to branch. Branch on carry, branch. I forgot what BCC is. You guys are going to, I'm sure in the comments, correct me. Anyway, so what we're going to do is we're going to decrement the ship's direction. The reason that we're doing it twice, let me show you up here, is I have a lookup table so that I have all the different directions defined. So if you're facing 12 o'clock, okay, let me show you this real quick. 12 o'clock means you're facing north, right? That's this right here, right? That's I wanted to store 2 attributes. One was the tile. The other one is the attributes. Do I want it flipped, left, right, you know, horizontal or vertical? Well, actually, no. It's just tile 0 and there's no attributes, so 0, 0. Well, what if it's facing off to about 1 o'clock? Well, now we're getting into tile 3, which is this one, right? Which is slightly off to the left. It looks like it's at 11 o'clock. Well, I want it 1 o'clock. So I'm going to flip it right here with the attributes, right? So flip it so it's actually pointing to 1 o'clock. That makes sense? There you go. So it'll flip over. So, and I just kept going through so that I had enough. And the more that you make this fine-tuned, the easier it is, or sorry, not easier, the smoother the animation will be. Okay? So anyway, that's how I did the lookup table. Just added 16 in there. I figured that was enough. Otherwise, it's too much and too hard to code because I still have to do movements and bullets and, you know, yeah, that's going to be a lot of fun. Anyway, so I'm going to decrement it twice so that I'm, you know, that's row by row. Okay. Now I'm going to load into the A register the ship direction that it landed on and test it to see if it's on the last row. Okay, if it is on the last row, okay, then I'm going to do, you know, I'm going to go down to rotate. Otherwise, it, I'm going to check to see if it's wrapped all the way around the table, if it's on the last row, okay. If it's not on the last row, then, you know, which is FE, then I'll break down into the branch of not equal. I'm going to go down to rotate, and I'll show you what that does real quick after this. Otherwise, you know, it has wrapped around, so I'm going to give it the second to the last value, which is 1 echo, and store that into ship direction. Okay, and then I'm going to go down to rotate. Remember, ship direction is just a byte. It doesn't actually do anything to the sprite. I'm just storing the row of ship direction. Okay, I'm just storing it. That's it. Cool. Okay, well, what does that do? Well, nothing yet. Okay. I know if your head's spinning, just maybe watch it a couple times or post some questions below and I'll explain it in a little bit better detail. Okay, so we're going to load 1 echo into the A register, store that in ship direction. We're going to go down to rotate. So once you get down to rotate, this is what I did. So we're going to transfer what's in A, okay, into the Y register. And now we're going to load into A ship lookup table Y. Y is just you know, the first row. Okay, in this case, the first index of the first row, so it would be the tile. Okay. Now, well, how do you get the second one? Oops, did I go too far? Yeah, I did. Okay, where'd he go? I went too far. Yeah, I did. Okay, here. Move. Sheep. Go back. There we go. Okay. Sorry about that. Where's rotate? Okay. So now we're going to store it into 0201. So now player 1 is actually moving, which is why I called this move ship 1, because I'm doing buttons 1. One thing I would really like to know, guys, is there a way for me to combine move ship 1 and move ship 2? Because I'm doing the exact same thing. I'm just looking at different, you know, down here I'm looking at buttons 2 and updating 0206 and 0205. Up here I'm looking at buttons 1 and updating 0201 and 0202. I'm wondering if there's a way to actually combine those two. There's got to be a way. Anyway, side note. So anyway, I'll look at ship lookup table plus 1. which will then look at the attribute. So this one is looking at the tile, which is the first row, first index. This is the first row, second index, because I added one to it. So that'll get me the attribute. Well, where do you store the attribute? In the third byte. So I'm gonna store it there. And that's it. And then jumps to the reset, okay, which resets the A register back to 0. Stores that in a movement timer, so that I can make sure that I'm still tracking, you know, the ship and where it's at. Okay, so basically this is what happened. Where is my code? There it is. All right, so open with messing. So we got in this combat, and when I first hit left, it's gonna go this way, right? Goes this way. Same thing for player 1. Left and right. And as you notice, the colors actually changed. I gotta fix that too, so the colors stay the same. The attribute, I zeroed out the palette, so I gotta keep the palette, you know, in there. So anyway, that's how it works. Let's try and make it move just a little bit faster. Just hair. Let's say I wanted it to spin, instead of every 10 frames, I want it to spin, let's kill that. I wanted to spin every, and I hope I'm using Screen-O-Matic. I hope Screen-O-Matic is going to capture this because it's going to spin really fast. But let's try 4. Every 4 frames. That's going to move. That's going to move. That's going to move fast. We'll reassemble it. As you can tell, here's my bank breakdown. I have a lot of space in bank 3 and bank 1 and bank 2. I'm only using up about 1/3 of bank 0, so I got plenty of code to write and fill all that stuff up. Alright, so now we're going to open this up and messing. Hopefully you guys can see this. Actually, it's not too bad. I thought it'd be a little faster. Oh well. It is a lot faster. I just thought it would be like mind-numbingly fast. That's actually pretty smooth. I think I'll stick with 4. It's not fast enough. Let's try 1. Let's go crazy. 1 frame per second. So it'll spin at 60 frames per second. I'll give myself a seizure. Watch this. Okay. Close that out. Alright. Reassemble. And now try messing. Alright. Grab the controller. There we go. Screen-O-Matic probably can't even catch that. You guys are like, it looks the same. Oh, trust me. If Screen-O-Matic is doing this at 60 frames a second, it is moving at 60 frames a second. That is pretty cool. So anyway, if I put a 2 there, you know, it'd be, instead of 60 frames a second, it'd be 30 frames a second. If I put a 3 there, you know, it'd be 20 frames per second, or move every 20 frames. Anyway, so on and so forth. The NES does not have the ability for floating points. You can't put decimals here, so I can't put like 1.5. You know, it has to be a decimal value. So anyway, you know, that's what you have to do. So thanks for joining me, guys. This has been fun. This game, it's going to take me a while. As you've noticed, I built the background here from all my tiles. You know, I gave them basic colors and whatever. Or no, sorry, here's the title background. The other one is actually level 1. I gotta rename it. My title palettes and title sprites, which are the 2, you know, jets. Anyway, it's been a lot of fun building the backgrounds and now building the controller movements. I gotta keep at it. There's so much more of this. I have a new appreciation for those of you that make games. So if anyone has made a Nintendo game, if you're watching this, more props to you. I know what to do, and I still have so much trouble doing it. So anyway, thanks for joining me on this little journey. Don't forget to like and subscribe, and I know there's going to be a lot of comments or questions on what I went over today, and if I've messed up anything, especially to Mike, if you're watching, please let me know, and I'll correct it in the comments below. Thanks for joining once again, guys. I will see you next time.